Hi everyone. Welcome back to Introduction to Programming. My name is John Duane and this is video number 6 in our series. So, why should I care about computer hardware? Well, many who are just starting out in computer programming are not interested in computer hardware at all. It's boring, they would say. They want to learn about coding and making the computer do wonderful things. Well, sure, I get that. However, there are two reasons why you should care about computer hardware. One, you don't want your program to be slow. And two, you don't want your program to crash the computer. Now, the way you can avoid these things is to understand the physical environment in which your computer program operates. So the purpose of this video is not to give you a crash course in the engineering behind modern computers. That's way beyond what I could do, but I simply want to give you a general understanding of disk storage and memory. Those are the two topics I want to cover. In later videos we might get into the processors where the real action takes place. That's a very interesting area, but for now we'll stick to disk storage and memory. But first, it's important to think about how data is represented inside the computer equipment. Think of all the different types of data: numbers, dollar amounts, words, pictures, and sounds. As incredible as it seems, all of this is reduced to ones and zeros. Since a computer is electronic, its basic language is binary, on or off, with an electrical charge or without a charge, magnetized or not magnetized. This is where bits and bytes come in. Every bit represents a single binary character, either 1 or 0, on or off. A byte is made up of 8 bits. Now both disks and memory chips are made up of millions and actually billions of bytes. They may look different under a microscope depending on whether you're looking at a disk or a memory chip. Yes, I did say microscope. These things are very, very small. But the bits are filling up the bytes. Keep all this in mind for later when we talk about data types. Some data types need more bytes than others. Alright, so with that in mind, disk storage. This is what I would call permanent storage. When you turn off your computer, the data on the disk remains intact. Most modern PCs have quite a bit of disk storage. My home PC, for example, has 300 gigabytes. That is 300 billion, with a B, bytes. The disk in a typical computer hard drive is a round platter, very thin, coated with a magnetic film. The bits and bytes are microscopic sectors in each track of the disk. The disk's access head writes data by either magnetizing or demagnetizing each bit to form ones and zeros. When this access head is reading data from the disk, it is moving over the disk and sensing the magnetic state of the bits. The magnetization persists after electrical power is cut off from the computer, so that's why disk storage is what I would call permanent. Alright, now memory. Memory is not permanent storage. In fact, sometimes it's called volatile storage. When the power goes off or the program ends, the data disappears. Most modern PCs have much less memory capacity than disk capacity. So actually we're going to switch our picture here. These are what memory chips look like. The screen before, those were all disk drives. So most modern PCs have much less memory capacity than disk capacity. Remember, my home PC had 300 gigabytes of disk capacity. Well, my memory capacity is only 4 gigabytes. And that's not a small computer, but still, that's an awful lot less. So 4 gigabytes of RAM, or 4 billion bytes of random access memory. Now, memory bits and bytes are encoded on memory chips, which are made of silicon, and that holds integrated circuits. These chips are electrically powered, which is why they lose their data when the power goes off. Now, moving data in and out of disk storage is much, much slower than memory storage. That's due to several factors, not the least of which is the fact that there's a mechanical arm that a disk uses to read and write the data. And there's no way that a physical arm can move at the speed of light, which is pretty much the speed that electrons have as they move through the integrated circuits. Okay, so what does all this mean to your computer program and its speed and its resistance to crashes? All right, well, first, whenever possible, use memory and not disk storage. Memory is fast, disk storage is slower. And two, because memory is so important to the speed of your program, be very frugal with it. Only use what you need. So you see there's a balancing act here. You want to use memory because it is fast, but you don't want to waste it because it might not be there when you really need it. Let's apply this to computer programming by learning about data types. And data types really come into the picture when we're talking about variables. So I'm going to switch the screen to data type screen. Okay, so what are variables in computer programming? Well, they are, first of all, a convenience. They're a storage container for data. They come in handy when you want to store a value for use later on in a process. It's hard to imagine a computer program without at least a few variables. I don't think, I can't remember anything except for maybe Hello World, where I didn't use at least 1 or 2 variables. In my opinion, a smart programmer will think about the type of data he or she is putting into a variable and then declare the variable as a data type that's consistent with what's going in there. So here's an example. Let's say you want to store a number in a variable. The number will never be greater than 30,000, and it'll never have decimal places. Well, then the best choice would be to declare the variable as an integer, because it only takes up 2 bytes and it can go as high as 32,767. So you can see that right here. Here's our integer. Only takes 2 bytes and it can go as high as 32,767. To declare it as a long, that would be a mistake, because a long takes 4 bytes, twice as much space in memory or disk, and it goes to a much higher number, which is not necessary. So as an aside, why 32,767 for an integer? Well, think about it. 2 bytes equals 16 bits. And how many possible combinations of 1 and 0 are there in 16 bits? Well, I'll tell you. It's 2 to the 16th power, or 65,536. So that means there are 32,767 possibilities less than 0 and 32,767 greater than 0. And actually in our example here, I guess we can go to 32,768 negative. So add those together and you come up with your 65,535, and then you've got one more character for the minus sign. So anyway, that's kind of binary in action. So if you're not careful with your data types, your computer program could crash. Let's say you try to put 40,000 into an integer variable. Its 2 bytes are not big enough for that number. The operating system would complain, and your program would crash with an overflow error. This happens when the program is trying to fit more than 16 bits of data into a 2-byte variable. That's not going to happen. So on the screen here you can see all the different types of data types that we have in VBA. We'll typically in all of our examples be using integer, long for really big numbers. We use double if we need decimal places. That's useful. Occasionally we'll use date, and we'll very often use string. String is where you'd put a text value. So those are the different types. Now we have an example where we're going to go over how the data types are actually used in code and how you would declare variables, but that will be in our next video. So I hope you enjoyed this. Please comment on the page and subscribe, and I will see you next time.